Hello and welcome to another lesson in the Advanced C# course brought to you by your friends here at Tuts Plus. Now this is a somewhat interesting lesson on a rather uninteresting topic, and why do I say that? Well, the topic that I want to discuss with you in this lesson is attributes, and the reason I say that it's uninteresting is that by themselves, attributes, well, quite honestly, don't do anything. And I'm not going to say that they're useless. They're very useful, but they don't actually do anything. So let's go ahead and jump into some code so I can really explain to you what an attribute is and really what it doesn't do. So here we are back in Visual Studio Express, and now I'm going to take you through a little bit of a walkthrough about what attributes are and what they don't do. So let's go to File, New Project. I'll create a new console application. I'll leave the name as the default and click OK. So let's start out with a brief introduction as to how you create an attribute and really what it is. Well, at its very basic, an attribute is nothing more than a class. So let's start there. Public class, sample attribute. So all we really need to do now to let the compiler know that this is an attribute is just make our sample attribute class inherit from the base type attribute. Now I can save and build this, everything builds fine, and we are done. You know almost everything you need to know about attributes. Well, that's not entirely true. There's actually a lot to know about attributes, and there's a lot of customization in there, but that's definitely a little bit beyond where I want to go with this particular lesson in this course. So let's see a little bit about what you can do with this now. So now that we have an attribute, what is its purpose? What do we do with it? Well, the base functionality and the base purpose for an attribute is to be able to assign metadata to code that you have written. So how do we do that? Well, it's quite simple. Let's just say we have another class down here and we'll call it test. And now we can assign metadata in the form of our sample attribute to this particular class by using the term decorating the class with an attribute. And the way that we do that is we open a square brace and then we type in the name of our attribute. So I'll say sample, but I don't see sample attribute in there. Why is that? Well, if you take a look at the IntelliSense here, it's telling us that this is actually a class, console application sample attribute. But one of the syntactical sugar things that C# does for us is say, well, yeah, I already know that this is an attribute, and it's somewhat redundant to say attribute when assigning the attribute. So it actually drops off the attribute that is appended to the end of the name if it's there, and just gives you the meat, right? Just gives you the sample here in this case. So that's fine, we can do that. But if you ever felt the need, you could definitely put the full name in here. It won't complain. You can build this. Everything will be just fine. But for simplicity's sake and for making me a little bit more comfortable, I'm going to leave it off because that's the way I tend to do it. So we'll go ahead and build. Everything builds just fine. We're good to go. Okay, well, what else? Well, you can assign by default, you can define a sample attribute to any part of your code that you want. So let's check that out. So right now I have it assigned to my test class, but let's say we have a property in this class and it's an integer called int value, and we have a method in here, public void method, doesn't take any arguments and doesn't really do anything. So we'll save that. So by default, as I said, you can assign any custom attribute you've created to anything you want. So I can assign it in here to my property, as well as dropping down a line here and assigning it to my method. There you go. I can save and build. Everything builds just fine. Wonderful. Well, let's say you wanted to restrict this attribute. Say it has a certain purpose, you have a certain reason for creating this in mind, and that you want to only be able to use this attribute to decorate a class for a particular reason. How would you do that? Well, quite interestingly enough, you actually decorate your attribute with another attribute to restrict its targets that it can be applied to. And that particular attribute is called the attribute usage attribute. And within that, it takes an ORD list of attribute targets. So if we take a look at attribute targets, you can see defined in here are quite a number of things. By default, it's specified as all, so if you don't give an attribute usage, you can apply your attribute to absolutely everything. And as you can see, you can define them to be applied to assemblies, classes, delegates, fields, methods, anything you want. So let's say in this instance, we want only to be able to assign our attribute to a class. So we would simply do this. We can save and build. And now we're not going to build properly because the compiler has noticed we've tried to apply our sample attribute to things that are not a class. Okay, well, we could either remove these or we could simply make our attribute a little bit more flexible. So let's try that out. So if we wanted to give multiple attribute targets to the attribute usage attribute, we would simply OR them together. And if you've ever done any development in C++, this might seem a little bit more familiar to you. And then all we have to do is give it the pipe command or the pipe operator here and say attribute targets dot property. Now if we tried to build this, now we've gotten rid of one of the errors, but we still have the other one because we are trying to apply an attribute that can only be applied to classes and properties to a method down here. Well, we can fix that once again by doing the same thing. Pipe attribute targets dot method. Save and build. Now everything works just fine again. So what's the big deal? Well, nothing yet, but we're getting there. So let's say that you wanted to actually apply some metadata to these things. Now, I've created this class, and now I can put the class in some fancy square brackets that are above a class, a property, and a method. Well, that's not really telling me anything. Maybe by looking at this, I can see that it's a method, but, big deal. Well, let's do a little bit more with this. So let's get this back down to basics here. So we're just going to apply this attribute to a class, and we'll get rid of these two attributes here. And now I want to actually give some purpose to this. And the way you do that is through properties. So I'm going to create a property within my sample attribute class, and I'll give this one a string type, and we'll call it name, and I'll also give it another property. This one will be an integer, and we'll call it version. Okay, we'll save that. Now, when I decorate a class with my sample attribute, I can do an open parentheses, and if you look at the overload, I can give it a comma-separated list of named parameters, and since the compiler did some reflection into my attribute, it knows that there are two properties defined, name and version. So let's go ahead and assign those. I can say name equal to John and version equal to 1. So we'll go ahead and save and we'll build that. Everything builds just fine. Now, what do we do with this? Well, in order for you to really understand some of the power of this, I'm going to show you a little bit of a taste of what's coming in the coming lessons, just so you can kind of get a feel as to, yes, there is some purpose to these attributes. I will watch the next lesson and I will pay a little bit more attention to what's coming up. So let's jump up into our main method here. And I'm going to throw at you two topics here very quickly, very briefly, that are coming in the next lessons. One being link and the other being reflection, which is actually in the absolute next lesson. So if you haven't seen these things before, if you're very unfamiliar with them, just hang in there. I'll give you a brief introduction, and then you'll get much more meat and potatoes in the next lesson. So I'm going to create a new variable, and I'm going to call it classes. Or better yet, I'm going to give it a name called types. Equal to, now this is where I'm going to jump into the reflection and the link. I'm going to say from T in assembly. Now assembly is defined in the system.reflection namespace, and I don't have that added to my file yet, to my project, so I'm going to do control period, and it's going to say, do you want to add using system.reflection? I absolutely do. So now as you can see at the top, it has been added in here for us. Wonderful. So now I'm going to say from T in assembly, get executing assembly, which just says look inside the current assembly that's running, which is console application 4. So do that for us, and within there I want you to get all of the types that are defined. So all of the types in this case right now are sample attribute and public class test. And you know what, just for yucks, I'm going to throw one more in here. I'll call this no attribute. Silly name for a class, but you'll see why in a moment. So now that we've gotten the types, and it's going to iterate through each one of those types and assign each one to the T variable. Now I'll say where T dot get custom attributes, but not only do I want to get custom attributes, I'm going to use a topic that I discussed in a previous lesson called generics, and I'm going to use the get custom attributes where I can ask specifically for my sample attribute. Now once I have them, I want to count them and make sure that there's at least one or more than 0. So now that I've done that, I'm going to select T, and that T is going to be added into the collection that will ultimately be saved in types. Now, if you didn't understand that, that's quite all right. I'm going to cover all this in coming lessons, but just take my word for it at this point. All right, so now we have a collection of types, which in our class are really just classes that have been found within this particular assembly, which at this point are only these, where the custom attribute, sample attribute, has been applied to that type. And what we can do is we can actually loop through these and say, for each T in types, I want to just do a console write line, and I want to write out the name of that type. So I save this and hit Control F5 to run it. And as you can see here, I've printed out test, which just so happens to be the name of the type or the class within this assembly that has been decorated with the sample attribute. Notice I did not get the no attribute because there's nothing there. There's no sample attribute being applied to that class or to that type. And the same with the sample attribute class, because I'm not assigning the sample attribute to itself. It only came back with test. And then once you have that class, you can do other interesting things with it, and I will leave most of those for the next lessons, but you could also do something like for each, say var p in t.get properties, and then do something like console write line p.name, and we can save that, and we'll do Control F5 to run it. And there we go. We have the type that was found within the assembly is test, and then we're going to loop through all of the properties found within that particular type and print them out to the screen. In this case, there was only one int value, as you can see down here. So hopefully you've seen a little bit about what attributes are, maybe not fully what they're very good at, and we're going to get to most of that in the next lesson, but I just wanted to give you a little bit of a feel as to how you create them, some of their usage, and some of the things you can do with them, and give you a little bit of a hint or a little teaser as to what's coming up in the next lessons. So stick with me as I show you part 2 of what attributes are and what they can do for you, as well as the very powerful counterpart to those attributes, reflection. I'll see you in the next lesson.